So here's what's left. I got the fins. It's actually held up okay, except for snapping out the whole thing. I added some styrofoam for stability, lower the center pressure a bit, and add some protection there. It's the drone I used. Let's see, nose cone here, didn't hold up too well, just 3D printed, so no big deal. Spin mass, it's pretty much smashed, but it didn't break. The ejection charge canister did alright. Part of the nose cone is still stuck in there. The Raspberry Pi did well. It recorded data the whole way through, didn't hiccup or anything. The digital potentiometers there. This helps control the motor. There's an IMU in there somewhere, but overall the electronics did what they needed to. Okay, so what went wrong? Not really sure. If I knew, I probably wouldn't have launched it, but I guess I probably needed a little bit more spin. I think I needed the whole rocket to spin. Anyway, I gotta think about it. I did get some useful data for analysis, so if I show this linear acceleration plots, this is the total magnitude linear acceleration. The bar at the far left is when I started my little launch script. You can see where it starts to jump up at about minus 28 seconds where I first lifted the drone. The second red line at minus 16, that's where the spin mass was stabilized. At 0, I actually fire the motor charge, and then about 3 seconds later, 2 seconds later, I'm firing the string charge. I'm supposed to separate the string from the rocket, and then 3 seconds after that, I was supposed to blow off the ejection charge, which shoots the parachute out. So if we zoom in a little bit on that same graph, again, 0 is right where I launch the ignition charge. I see there's about a half-second delay from when I want to launch and when the motor really starts going. So that's actually pretty useful data. I thought it might be up to 2 seconds. That's why I waited so long to blow up the string. Interestingly, you see the peak value there is about 20 meters per second squared. And if you like physics, you run through the math. Like, I was using an SD's E9 engine, which has a peak thrust of 25 newtons. And my motor, or the whole rocket, weighed about 750 grams. So the net upward force would be 25 minus mg there. You get about 17.6 upward newtons of force, and then force is mass times acceleration, so you figure out the acceleration is about 23 meters per second squared. So actually pretty ballpark there, but kind of cool to see. Second thing is I did try to blow up the string. I'm not sure if it did, but then that huge bump, the second one right there, that goes up to about 48 at 2.3 seconds, that is where the string actually pulls the drone and completely changes it, pulls the rocket, completely changes the angle. And you can actually see in the drone video, the drone jerked a little bit too. So that's a failure in separating the rocket from the drone. So that's what led to that huge turnaround. And then you see it crashes at about 4.5 seconds, so right into the ground. So my ejection charge actually would have went off after it crashed, so not too useful there. So I get a lot of cool stuff on this. Other sensors, like if I look at the pitch angle, to see like 0 degrees would be straight up. Kind of shortly after the rocket really starts going, it pitches over to the side. So that's kind of a total failure. Really wanted that to sit at 0. Let's see. I get a bunch of temperature. You can look at the temperature graph. It's kind of hot in the outback that day. Get some gyroscope data, kind of see the rotation about the z-axis. So partly I wanted the mass to start spinning inside and the rocket would spin the other way as like a counterforce, and then eventually the tension in the string would cause the rocket to start spinning back again, which was a goal that didn't happen obviously, but this is like a magnitude of the spin that was on the IMU. So I got a lot of cool data. I also got stuff like magnetic field data, but not as useful as anything else. I put all the code I used to plot these things and that was running on the Raspberry Pi and the log files on my GitHub, which I just put up in case you're interested. But yeah, there you have it. Total failure.